In this video, we look at the specific law which tends to be at times a bit problematic. Although logarithmic laws and their application in general does pose a bit of a problem at first, it is important that many exercises are completed in order for students to fully comprehend the application of the laws. In other words, do as many examples as you possibly can. Now, in this logarithmic law, the change of base law, it's a fairly, hopefully straightforward law. Now, there are proofs to all of the laws that you use, but you do not need to know the proofs of these. So I will not explain them. However, you possibly would come across them in many textbooks and online ebooks. So what is this particular law? Well, there it is. The log of a term y to the base x. So that's your base, and that's the term or the argument. That can be written as the log of that term y divided by the log of the base x. In other words, it can be written as a fraction. And then you can choose any base that you wish. So it's pretty simple, I hope. You simply given a particular log, and you can write that out as a log of the argument or the term divided by the log of the particular base. Now this becomes extremely useful in cases where the bases are not standard bases or natural logs. There we have an example right here. The log of 8 to the base 4. How do we simplify that? Well, we simply apply the change of base law. The term is 8, the base is 4, so that can be written as the log of the term 8 divided by the log of the base 4, and then I can decide whatever base I want to choose. So I'll just leave it like that because that's my standard base 10. And now I can simplify. And of course, please, if you are sitting watching this video and you are thinking, oh, this is so easy, that answer is 2. Start the video again. Go to a shower, go get a cold shower, and come back. And have a look at all the logarithmic laws. How many times have I told you, you simply cannot cancel off log because log is the word log. It's a sin to do that. You have to view this entire term, log 8, as inseparable. Log must act on something, so you can't separate those. So how then do we go about doing this? Well, now we simply use powers. I can write that as the log of 2 cubed. Divide that by the log of 2 squared. And then I can use the log law 3. That becomes 3 log of 2, and at the bottom 2 log of 2. And now when I cancel off, when I do cancel off in this case, it will be cancelling off this entire log 2 like so, giving me the straightforward answer 3/2. There's an application of your change of base law. Let's just do another one. Take, for example, the log, it could be linear as well, the log of 1/3 to the base 27. That's the term, that's the base. So that would be log in the numerator will be the log of 1/3. The denominator will be the log of the square root of 27. Then I start using the same processes, but of course follow the simple, straightforward exponential and logarithmic laws. For example, 1/3, I can write that as the log of, yes, 3 to the power minus 1. What about 27? That can be written as 3 cubed. And now the minus 1 can come to the front, minus log of 3. What about the square root of 3 cubed? Well, there we have to go to our exponents. What do we know? How do we go about writing a square root, a third, as an exponent? A to the power 1/2. The 1 is from the exponent of A. The 2 is understood to be the root. And I write that as a fractional index. What about the 5th root of B cubed? Can you write that as fractional index? What will that be? B to the power? That's right, 3/5. So in this case, what would this become? The log of 3 to the power 3/2, because that's understood to be a 2. And then that 3/2, of course, can be taken to the front of log of 3 using our appropriate log laws. Log 3 cancels out. I'm left with minus 1 divided by 3/2, which gives me negative 2/3 as my answer. There's your application and the change of base law in action. But notice, it's only the first step. It's just the first step. Once you have the first step sorted out, then it becomes simplification using exponents and all your log laws, and algebra included. Now, this is a variation of the change of base law, and I'm not going to prove it. So I'll just explain it. The log of y to the base x. Now, in this case, the base is x, and the term, the argument is y. What happens if in a problem we want it the other way around? We want the y as the base and x as the term. Then I can do that by inverting it. So log of y to the base x is equal to 1 divided by, and then I switch the x and the y around, log of x, and the y now becomes the base. And of course the reverse is true. So for example, if I have, let's say, the log of say 7 or 8 to the base x, and I don't want that. It's not convenient in mathematics to have a variable as a base. You would like the 8 to be the base, so you want these two terms, these two values to switch around, and you can do that using this law. So what will that become? 1 divided by the log of, now switch them around, x to the base 8. Now I have a nice natural number as my base. So let's look at an example. Solve for x if log of x to the base 7 plus the log of 7 to the base x is equal to 2.5. And just before I actually start that, you could also, of course, in this, well, let's look at this particular example. You could use the change of base law. In other words, you could do that But then you start getting fractions over fractions, and it makes it a bit more complicated. It may be more convenient to use this version. So let's have a look there. There's a 7 as the base, but here's an x as a base, and there's my 7 there. So all I need to do here is this term, I just need to switch these around. So in my solution, I'll leave the first term because it's got a nice natural number as a base. And then I switch these around, but when I switch, I must invert them. So it'll be 1 over the log of x to the base 7 is equal to, and of course 2.5, 2.5, that's 5 over 2. And there we have a nice logarithmic equation that we can solve. We could solve it as it is, but maybe let's make it a little easier. What do you think? What could I do to make this equation a little easier to solve? Because I need to multiply by the LCD. 2 log x to the base 7 may become a little complicated. What would you do? That's right. You'd introduce, what did you learn at school? Your k. Let log of x to the base 7 equal to k. So wherever you see that, that becomes a k. 1 over k is equal to 5 over 2. There you go. An equation which is easy for you to solve. Multiply by your 2k. You're going to get 2k squared plus 2 is equal to 5k, a quadratic. Solve the quadratic. Factorize. This works out quite nicely. I don't need to use my quadratic formula. 2k minus 1, k minus 2 equal to 0. So 2k minus 1 equal to 0. K minus 2 equal to 0. K is equal to half. K is equal to 2. Is that complete? Not at all. I asked you to solve for x, not for k, but we know what k is. So now we're going to substitute for k. Therefore, let's turn over. Let's get more space. Therefore, the log of x to the base 7 is equal to the half. That's the first one. Or log of x to the base 7 is equal to 2. You want to double check? There you go. Half and 2. And now, how do we get the x? From the very first slides of logarithms. Change from log form to exponential form. What's the base? 7. What's the index? Half is equal to x. So x is equal to the square root of 7. And over here, x is equal to 7 squared, which gives me 49. Yes, that's complete, but maybe just one more thing. Let's just double check that x there must be greater than 0. So that's a restriction. Our restriction is that that argument x must be greater than 0. Did I say 7? Okay, must be greater than 0. Yes, it's greater. Yes, it's greater. Therefore, I accept both answers. And there you go. That is complete. There's my answer. Short video, but emphasizing change of base. Brings this video lecture video to an end.